All right, guys, let's look at lesson 2, which is the nature of energy. So first, what does that mean? We already talked about the wave nature of light, the fact that light travels in waves, but that doesn't explain what happens when your temperature increases. So Max Planck explained that it can be assumed that energy comes from packets called quanta. So quanta are little packets of energy. What he did is he went off of what Einstein said. So we've already talked about this when we talked about Einstein's article. So Einstein used this assumption to explain the photoelectric effect, that he concluded that energy is proportional to frequency. So E is energy is equal to, this is Planck's constant, and V is frequency, or nu is frequency. And H is equal to 6.626 times 10 to the minus 34th joules times seconds. So remember, he talked about this. So if you hit a metal surface with energy, it's going to emit electrons. Those electrons are going to create energy, and you can test that. So what does that mean? If you know the wavelength of light, then you can calculate the energy of the light, and we can use our equation that we learned in lesson 1, which is C equals lambda nu. So now we have H equals, or E equals H nu, and we can put them together where we can, if we know the wavelength of light, we can figure out how much energy it has. So E equals Hc over lambda. And this equation at the bottom is a combination of these two. So let's put these equations into practice. So let's look at an example. Determine the energies of photons with a frequency of 4.5 times 10 to the 14th seconds, or to the minus 1, or hertz. So here's our equation. E is going to be equal to Planck's constant, which is 6.626 times 10 to the minus 34th joule times seconds, times our frequency. So that's a straight plug into your calculator and solve, and you get your energy is equal to 2.9817 times 10 to the minus 19th joules. Let's look at another example. What if you wanted to determine the energy and you were given the wavelength? So this is going to be the equation that you're going to use. E equals Hc over lambda. And so E is going to be equal to Planck's constant, which is a known value, times our frequency divided by our wavelength. When we divide that by our wavelength, we get 7.45 times 10 to the minus 13th joules. Try practice. Determine the amount of energies of photons with a frequency of 4.50 times 10 to the minus 14th. Pause the video, unpause when you're ready. Great, well, what did you get? You should have used this equation. So E is going to equal to Planck's constant times our frequency, and we get 2.98 times 10 to the minus 19th joules. Awesome. So check your understanding. Determine the energies of a photon with wavelengths of 700 nanometers. I'll give you a hint. We're going to go over this in class tomorrow, but you're going to have to convert this to meters first. So look back in lesson 1 on how we did that. See you tomorrow.